Hello everybody, today we're going to talk about transforming functions. So g is a transformation of f. The graph below shows f as a solid blue line and g as a red dotted line. What is the formula of g in terms of f? So blue is my original, red is my new. Is the red one 2 times f of x, half times f of x, or f of 2x? So what I did is I went to our favorite tool, GeoGebra, and I just graphed a cubic. This is just, I think it's negative x cubed plus 2x, just a cubic. And I want to see what happens when I do those different things. So the first thing I did is I went and I made it y equals f of 2x. And I got this graph. So this black graph right here. So as you can see, what happened was it looks like it shrunk it horizontally, right? It pinched it horizontally. This is now in here, and this is now in here. So it pinched it. Didn't change the height at all. If we go back to our problem, it looks like this is not pinched. It just changed the height. So I don't believe that f of 2x is a good choice. That's not a good choice because f of 2x pinched it, made it narrower. Okay. Next I went to, we'll take that one off. We'll put, this one was, I believe, y equals 2 times f of x. So this one made the humps higher, made them taller than what they were on the green one. Okay, so if we go back, it looks like two of these makes the humps are taller. So 2 times f of x might be a good choice. Let's look at the last one, the last choice, and that was y equals 1/2 times f of x. That was this one. And this is the black line again. It looks like it made the humps not as tall, right? So which one of that, and obviously our humps are taller. The red humps are taller than the blue humps. So which one do we pick? Looks like we pick 2 times f of x. Okay, so here's another graph where g is a transformation, and they want to know what is the formula of g in terms of f. So let's take a look at f of x plus 2. Now last time we had times 2 in here and it made it narrower, remember? So let's see what happens if we have f of x plus 2. So again, I went to GeoGebra, our favorite tool, and I just put on a cubic, and this right here would be f of x plus 2, and it shouldn't be any surprising when it's inside the grouping symbols what happens. It gets shifted left 2, right? So probably f of x minus 2 will shift it right 2. So that leads me to believe that maybe this one, f of x parentheses minus 2, will just shift it down 2. Okay, the thing that just kind of tricked me out was like these, like if you think it's just shifted down to, maybe this should be like parallel, quote unquote parallel to this line, like looks like it never touch, but that's not what happens in a curve. So I believe that it's going to be this last one, f of x minus 2, because this one shifted it left 2, this one shifted it right 2, this shifts it down 2. Okay, same type of problem. We got to figure out what this is going to do. Let's think about this. F of 3x. This made it narrower. This is not narrower. F of 1/3 x made it wider. This is definitely wider. And 1/3 f of x. One was f of 2x that made the humps taller, right? So f of 1/3, excuse me, y equals 1/3. So y equals 1/3 f of x will probably change the hump height, quote unquote, on this. So let's go back to GeoGebra, just take a look, just see if we can find a pattern. There's my original. This one is going to be f of 3x, so it made it narrower. Not only did it make it narrow, but it shifted the vertex over too a little bit, didn't it? Let's take a look at f of 1/3 x. Next, there's f of 1/3 x, made it wider, but also it shifted the vertex. So finally, this is 1/3 times f of x. Vertex stays basically the same, just the hump size changes, right? This is bigger. It also made it wider. So looks like we're going at the last one. Okay, I want to look at a couple more. F of x plus 5. This will move the curve up 5, right? 1, 2, 3, 4, 5. Looks like a pretty good guess. F of x minus 5, since it's outside the grouping symbol, it's going to move it down 5. 2, 3, 4, 5. Down here, not so much. F of x plus 5 inside the grouping symbol, it's going to be right and left. So this is x plus 5, so it's going to shift it left 5. 1, 2, 3, 4, 5. Looks like we're going with this first one. Up and down shift. Right. Next, G's transformation. 2 times f of x, negative 2 times f of x, and 1/2 times f of x. So I don't know if you remember, but last time we had 1/3 f of x, and that made it wider. So this looks like the candidate I'm going with because it's making it wider. 2 times f of x would make it narrower. Now, so if I'm multiplying the entire function by 2, it narrows it, but 1/2 would widen it. So anything between 0 and 1 makes it wider. Anything bigger than that would make it narrower. This one makes it narrower, but also with this negative 2, it flips it, so it would be up here, right? It would go like this. So I think it is this one. Okay, so here's one. F of x minus 2, this would shift it down 2. F of x plus 2 parentheses, this would shift it left 2. F of x minus 2, this would shift it right 2. Blue's my original, going to my red, I want to shift it left 2. That's this one right here. Okay, this one. Looks like I'm just shifting this up 1, 2, 3, 1, 2, 3. So shift up 3 would be f of x, and then plus 3 on the outside. Okay, so what did we learn? We learned a few things. We learned when it's outside the f of x, it shifts it up and down. We learned when it's inside the f of x and it's a plus, it shifts right and left. We learned at times inside the f of x, squeezes it or makes it wider. Sometimes it'll change the vertex. We learned that a 2 multiplying on the outside of f of x makes my humps taller. So those are the things we learned. Let me know if you have any trouble with this. Talk to you later.